Okay, so let's talk about reactions involving acids and bases. So whenever you have an acid, let's say you have vinegar, and you mix it with some type of base. So let's say, oh, that stuff. We put it in bread so that it'll help it rise to make some bubbles. That's right, baking soda. So when we're talking about acids and bases put together, this is called a neutralization reaction. So we have an acid, and we're going to add a base. You're basically going to get a blending, okay? Something that is not acidic or basic. So we call it a salt, and water is going to separate out. In some cases, you can see bubbles being given off. That's showing that a chemical reaction is occurring. And for the most part, neutralization reactions occur well if there's equal mole amounts of an acid and a base. So if you have the same number of acid particles with the same number of base particles, you're going to have a neutral reaction, meaning it's going to be roughly in the pH of 7. However, if you have something more acidic, like a lot more vinegar than your baking soda, then you're going to be left with it being slightly acidic because there is not an equal mole ratio. There's more acid than there is base. So the best known example, looking at the different types of acids and bases, would be looking at hydrogen chloride, which again is aqueous, and then NaOH, which is basic. So what happens is, and I'll just show you, when we're talking about an acid, we are talking about, let me just erase that and circle it. Let's do some highlighting. That hydrogen is what matters. This hydrogen is going to leave. It's going to leave, and it's going to attach to this, making it water. The OH, which we know to be a base, is going to be used to match up with that, which is going to be found in the water. Okay. And as you can see, what's left over, which would be, I'm going to indicate this with green, that Cl and that Na are going to get together and create that salt. And again, you know it's salt because it's a metal with a nonmetal. So what they want you to do is we want to predict the products of and balance the following equations. So most of these are going to be acid plus base making a salt and water. So there's a couple of different ways you can do this. Okay. We do not have to predict the products because they're giving it to you. But in the future, you should always know that it will ultimately come down to this equation type. So some acid plus some base will make some type of salt and always water. So what we're going to do here is we're going to do some predictions. Okay. So they're going to ask you to balance it out. SO4 stays the same on the left as it does the right. I'm going to keep it the same as it is, left on the right. Okay, so I have 2 hydrogens, 1 sulfate, 1 sodium, and 1 hydroxide. On this side, I have 1 OH, 1 sulfate, and I have an Na and an OH. Now the reason I keep it this way is that I know that the hydrogen's being given off by the acid and it's going to get together with that OH on the base. So I'll keep it written like this so that I can balance it a little bit easier. I have 2 sodium and I have 1 hydroxide. So to balance this, I'm going to put 2 on this side. That's going to change my hydrogen. And then I'm going to change this, which is going to change my Na, my OH. So that would be a balanced equation. And again, it takes a little bit of getting used to. HOH is the same thing as H2O. But if we can kind of keep it in the format of, well, this OH came from here. This OH came from here. And this hydrogen got together and went there. This hydrogen went to go there. So that way I can kind of keep tally of what it's going to look like. Second thing, okay, so we would take it HCO3, calcium, and a hydroxide. Two of those, 1, 1, and 2. I have one hydrogen, one carbonate, one calcium, and one hydroxide. So all I have to do is make that a 2. I've made 2 hydroxides, 2 hydrogens, and we are even Steven. So just to kind of keep you relating back to the different types of equations there are, this is considered a double replacement reaction. Okay. The metal from one goes with the nonmetal of one goes with the other nonmetal. So this double replacement reaction is specifically, when you talk about acids and bases, a neutralization reaction, which is a type of double replacement.